morning, students. Right now on the screen you are seeing a person swimming along. Now, why am I showing you this? Well, you will come to know about it by the end of the video. Before starting, I would like to ask you, do you remember what we studied in the last video? Yes, do you remember? We learnt about uniform and non-uniform motion, difference between the two, and we also studied about average speed. So, what are we going to learn today? Today, we are going to continue with the next part of this lesson, which is speed with direction. And also, we are going to study about a rate of change of velocity. So, let us start first with speed with direction. Let us know about it. So, speed with direction. When we specify the direction of the motion along with speed, it becomes velocity. So, what is speed with direction? It is nothing but velocity. The velocity of the object can be uniform or it can also be variable. Average velocity of the object is given by. So there is a mathematical relation for it. Average velocity is equal to initial velocity plus final velocity divided by 2 because it is average velocity. So relation is u plus v divided by 2. What is u? Initial velocity. And what is v? V is a final velocity. I hope you understood what is velocity. Velocity is nothing but calculation of speed with direction. Okay, so here we have to consider speed along with direction. How do we calculate average velocity? You have to add initial velocity and final velocity, and then you have to divide it by 2. As simple as that. Now students, do you remember what was average speed? Average speed was total distance traveled divided by total time taken. So you have to understand the basic difference between the two. So let us learn difference between speed and velocity. So here comes speed and then velocity. First point is related to speed. Speed is the rate at which an object covers distance in particular time. What is speed? Speed is rate at which an object covers distance in particular time. Then what is velocity? Velocity is displacement of the body. I repeat, velocity is displacement of the body measured per unit time. Okay, so here there is distance in speed and in velocity there is displacement. So this is a difference between the two. Then speed is a scalar quantity. What is scalar quantity? A quantity which has magnitude alone, that is called as scalar quantity. Velocity, obviously it is opposite to speed. It is a vector quantity. What is vector quantity? A quantity which has both magnitude as well as direction. Understood? Let us see the third point. Speed is equal to distance upon time. And what is velocity? Velocity is displacement upon time. That is also a basic difference between the two. So these are the three major differences between speed and velocity. Now, before moving to the next topic, can I ask you something? Do you know the difference between distance and displacement? Let us see. Let me ask you. There are two lines that you can see here. One is a violet line or bluish line and other one is a red line. A red point is moving along the path A to B, B to C, C to D, D to E, E to F, F to G and so on. Can you guess which line represents distance and which line represents displacement? Can you guess it? You might be correct. The blue line or the violet line is a distance line, whereas A red line is a displacement line. How to recognize the difference? A distance is always an actual path followed by an object, whereas the displacement is the shortest distance between the initial point and final point. That is what we call it as displacement. I repeat, what is distance? Actual path followed by the object. And what is displacement? A shortest path between initial point and the final point. Understood? Now I want to ask you, when a car moves or runs, does it always travel with the same speed? Answer is obviously no. Because before starting, its velocity is 0, and then as it starts, its velocity goes on increasing. While running also, on turns and wherever there are speed breakers, its speed and direction changes. In short, its velocity changes. Almost always. Now we are going to learn something about this change in velocity. So the topic's name is rate of change of velocity. During uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any time interval is 0. In short, during uniform motion, since the velocity remains constant, the change in velocity is 0. However, in non-uniform motion, velocity varies with time. Example, just now we saw in the animation where car was moving around and its velocity was changing, and that was a non-uniform motion. So in non-uniform motion, velocity varies with time, or it changes with time. Therefore, the change in velocity of the object during any time interval is not 0. I repeat, the change in velocity of the object during any time interval is not 0. Can we measure it? The answer is yes, we can measure it. The change in velocity when measured per unit time is called as acceleration. So what is acceleration? Acceleration is change in velocity when measured per unit time. Let us see the relation for acceleration. Acceleration is equal to change in velocity divided by time taken. How can we put it mathematically? Mathematically, A is equal to V minus U upon T. What is V? Final velocity. And what is U? U is a initial velocity. So V over here, it is a final velocity, and U is nothing but initial velocity. So final velocity minus initial velocity divided by time is nothing but acceleration. Now that we know what is velocity, what is rate of change of velocity, we can solve at least one problem related to these topics. Not all of them, but at least one. So right now we are going to solve a problem related to velocity. The problem reads, Usha swims in a 90-meter long pool. So length of the pool is 90 meters. She covers 180 meters in 1 minute by swimming from one end to another and then back along the same straight path. So total distance that she covers is 180 meters. Find average speed and average velocity of Usha. So you have to find both average speed as well as average velocity. Let us see the solution for it. Total distance covered by Usha in 1 minute is 180 meters. What is the displacement? Displacement will be 0 meters. Why 0 meters? Because she is going at one end and then she is coming back to the same point where she started. So displacement is 0. What is average speed? Average speed is equal to total distance covered divided by total time taken. What is total distance covered? 180 meters. And what was the time taken? 1 minute. But 1 minute you have to convert to seconds. So 180 divided by 60 seconds, because 1 minute and 1 minute will cancel each other. So what remains is 180 meters divided by 60 seconds. So what do we get after dividing it? We get 3 meters per second. So what is average speed? Average speed is 3 meters per second. Now we are going to solve for average velocity. Average velocity, do you remember what is the formula? Yes, average velocity is displacement divided by total time taken. So what was the displacement? Displacement is 0 meters, because Usha is coming back to the same point. So displacement is 0 divided by 60 seconds. So what will be the answer? Obviously 0 meters per second. So did we find both the things? Speed as well as velocity? Answer is yes, we found both. Average speed of the Usha is 3 meters per second and her average velocity is 0 meters per second. I hope you understood the difference between velocity and speed. So, did you realize why I showed you animation of swimming? It was because I wanted to solve a problem related to swimming. So that was Usha, who swam along the pool of length 90 meters. She went along and then she came back and again swam for 90 meters. So total distance that she covered was 180 meters. Though she traveled 180 meters, the displacement was 0. Why? Because she came back to the same point. I hope you understood the topic now. Now let us move to the assignment. Our today's assignment consists of 4 questions. First one is define velocity. Second, distinguish between speed and velocity. Third, what is acceleration? And fourth one is a numerical. Numerical reads, Milkha runs along a track of 100 meters. He covers 200 meters in 20 seconds by running from one end to other and back along the same straight path. You have to find the average speed and average velocity of Milkha. It is just like a numerical that we just now solved. Okay? I hope you can solve this very easily because we have discussed all the points. If you have any doubts, please ask me. Until then, take care, bye bye, and have a nice weekend.